Hello everyone, it's Dmitry and Surfalytics, and today we'll continue to answer the questions. And the questions I've got today talk about data quality, frameworks for the data quality, and how we can use the data quality. I agree. This is a very popular question on the interview. Doesn't matter the role. It could be data analyst, could be BI engineer, analytics engineering, data engineering, even for data science and machine learning. The data quality is important. Overall topic of the data quality is extremely important. Just to build pipeline, like data pipeline to load data from source to the target, apply some transformations and maybe build some dashboards. It's not that complicated and very straightforward approach. But how you can make sure that metric in your dashboard, for example, even revenue or number of orders the company sold last week, is accurate enough? How you can make sure that there is no any issues with duplicates or missing values, and where could be anything happen? One thing is very important to understand about data warehouse or data lake house, those systems that built for analytics. It's whatever you put in, you get out. So if the bad data go in, you get the same bad quality data. There are techniques that are very helpful to establish and improve the quality. And they're not complicated. In many cases, you even don't need to use any expensive vendors and solutions. You can just use the plain SQL, sometimes or Python, whatever you want, just the common sense. And I will talk about some of the approaches. I will try to keep it to the specific framework as usual. We'll start drawing. For example, could be the case you have the database. This could be sales orders, your backend database for whatever you have. Let's talk about online store as usual. So online store selling orders with backend database. Maybe you can use this payment provider, and it could be Stripe, or maybe using the Salesforce. Let's use the Salesforce because usually the Stripe as a payment provider is the most popular payment provider. The company using subscriptions for invoicing, for payments. It is still possible to make a mistake. For example, how you can mistake if someone going in the Stripe and will change subscription rules or whatever in Stripe, but in your data warehouse you have still like initial sync and initial record, the probability will be different and reporting value will be different. But it's quite complicated case. I don't want to go into details for this right now. Just trying to assuming we will use the instead of Salesforce. The Salesforce, the most popular customer relationship management software, so you can have your customers there, you can have your partners, vendors, just to manage all together. And assuming with the call center, they're using Salesforce to contact the customers and keep record of the customers. And maybe you can sell to the customer sometimes just single order, sometimes bulk orders. Everything is controlling maybe in Salesforce. It doesn't really matter. So the database, and here we can have our bigger data warehouse. We somehow building the extract, transform, load, our pipelines, or could be extract, load, transform. You should know the difference. And Salesforce usually we accessing for API. And the data is coming here. On the other hand, we have our beautiful dashboards. Our maybe KPI metrics, some visuals, and it's connected to the database. And what we can now talk, this is a very simple use case. It could be more complicated, could be more sources, could be different storage, could be different options here. It could be streaming. Now we're using just the batch, or it could be different consumers here. It could be not just BI dashboard. We can, for example, write back to Salesforce or write back to the different API for the marketing campaigns. There are so many different things could happening here. We should just understand the very simple things. If we understand the simple things, we can move to the more complicated. My overall approach in Surfalytics that we always start from the simple things, because if we can understand the simple things and can understand how the things working from top level, high level overview, it will be quite easy for us to moving from like next level of complexity. So what we can do, assuming it's the batch, assuming it's just the ETL, maybe running once a day. We copying data from here and writing into here. And usually inside data warehouse, we can split it into parts. One is our staging. We're trying to replicate, if here in the source database we have 10 tables, we're going to replicate 10 tables here, maybe in individual schema. If in Salesforce we want to replicate like 20 tables, we'll have another schema here and we will replicate those 20 tables, usually one-to-one. And what can we do? Default checking, and the tip is here. There's actually two tips I can give you here, how to better understand this. Usually I rely on the vendors, and one of them is dbt. So dbt quite popular because it has many advantages for the data transformations, but out of the box dbt provides you lots of testing functionality. Basically dbt is just the SQL framework. It's how you define your transformations using the SQL, and for each SQL transformation dbt calls dbt model. Assuming you have your SQL transformations, that may be just reading, so you define your source tables. You copy data here, you have a table. So for example, you create the new table. I can have tables orders. So we're moving this table from source to here. We replicate it every day. There are different strategies how we can replicate it, but we have tables in our stage. It's basically replica of this production table, and we have it here. So the things what we can do, and dbt very helpful here, but we can do it without dbt too. So the things that we need to avoid. First thing, we're gonna to check, is it like not null? So we maybe some values, they more important. For example, order ID. We shouldn't have order ID now. Null means nothing. We don't want to have it. That's the one thing. And we can apply this rule for every column inside the table. The second one, the test calls uniqueness or unique. It means that we don't want to have in our table any duplicates. Imagine you have the order ID, somehow you have duplicate, right? Duplicate means you have the exact the same row or record in the table. In our table orders, we can assume that the unique key is the order ID. It means there is any single point of time where it should be only one order ID exists in this table. That's why the uniqueness test makes sure that for each order ID, we'll have only one row in the table. If somehow for one order ID we have multiple records per table, it means duplicates. But it's very important here to define the primary key. The primary key of the table, it's basically coming from database theory, but the idea that the primary key is defined the unique record of the table. You don't need to invent the bicycle to think what's the primary key, because usually you're getting this from source database, and usually if you see DDL, you should know what is DDL. You see DDL in the source table, you can spot the primary key. Because usually for OLTP databases, again, another term, OLTP, we covered this, what is this? You should know. OLTP database, they usually have pretty normal, like normalized data model, and each table has the definition for the primary key. This is the ideal case. If it is not the case, then you need to, using the SQL, to find what's the unique record and confirm with the owners, maybe backend engineers, whatever team is owning. So you need to find the unique key. And then you can say, you can just check that this table doesn't have any duplicates. Another test that easy to do, is to implement, is freshness. It's very helpful. Imagine our first step here, we're replicating tables to the staging. And our next step here, we want to do some kind of updates for fact tables, and actually our metrics that we're going to report in BI, sales, orders, any kind of information. And the idea here that business users, their expectations, whenever they open the dashboard, the data should be accurate. And accurate, it means there is no like null values, there is no like duplicates, the data is fresh, and this is the expectations. And we don't want somehow to get stale data here, assuming somehow ETL job is run, it's success, like it finished, it means we replicate the orders tables, then we refresh fact tables, we have our sales fact table, orders fact table, ready to refresh our dashboard. If this data is not fresh, even if ETL job is succeeded, the data could be still not fresh. It means we don't want to refresh the fact table. We don't want to screw anything about this. So that's why the freshness test, just to make sure that the last available, for example, order date in this table is less than like 24 hours. It depends to your cadence. If you refresh your data warehouse once a day, it could be like 24 hours. If it's every 6 hours, then it's like 6 hours, and so on. So you define those rules. You can establish SLA, like service level agreement, with the business that the data available in data warehouse will be fresh enough. So those three things, this is your foundational things. Another thing that more complicated is actually how you're gonna test the business value. And for example, if we talk about quality for the metric, number 4 metric. For example, we talk about orders. We can say that the particular metric can be greater than 0, could be negative. This one case. Another thing that our revenue should be less than million per particular order. Also, we can trying to handle outliers. For example, if you see that every day you have, 1,000 orders a day, then you can calculate moving average for the last 7 days with number of orders. That will be around like 1,000. Yesterday or today number of orders, you will compare against this moving average. This is very simple rules. Even this can help you to get like proactively react on the issues. Another thing about all of those things, you can actually decide what to do with them. Sometimes you can completely stop and shut down your pipeline and send alert, maybe to the Slack, maybe to email, maybe trigger engineer on call, that something going on with this, and we don't want to refresh anything. Sometimes you just want to get the warning, maybe not null is not that critical, and we actually get the null values. We don't want to break anything, we just want to get little message that there is null values, but it's not that critical. Another test I know it's very good, for example, for product types or the product names, calls accepted values. Accepted values. For example, if your company has like just 10 product names, you want to stick to those 10 product names. Could be the issue in supply chain or somewhere that your product name is misspelled, and you want to proactively find this as soon as possible. If you have the acceptance values for your product names, you just list your 10 products names, and they should be matched. If something off, you can get warning, or you can get failure alert. And there are pretty big list with those things. I just grabbed those ideas from dbt. So if you check dbt tests, it has really nice idea what kind of tests exist. As you know, dbt works well with data warehouse, but if you talk about data lake or lakehouse, like Databricks, Trina, Iceberg, then you still can rely on dbt, but there is alternatives, especially if you work with the Spark. You probably with Spark with very different approach. With Spark, you can either use the, for example, PyTest, and the PyTest is simple assertions. You can do all the same, and basically after your pipeline, you can run simple assertion that number of unique rows per ID equal the number of rows, and so on and so on. So this is just one of the examples. But again, if you just understand vendor agnostic, what use case exists, then you can actually think, okay, do I have the data warehouse? Then I probably can rely on dbt, or maybe I can use, for example, very popular open source library, Great Expectations, where we can define the test, or maybe we can go with the service like Monte Carlo. And I used to work with Monte Carlo. It works nice. You can set up different monitors. They even will start checking your schema change and other tests, like how many records every day you insert to the table. So if you have incremental load, and every day you adding 1,000 rows, but somehow once you added to this table 10,000 rows, so you can get alert instantly that something strange going on, and you can check. Monte Carlo is a really nice tool, and if you go to the Monte Carlo and check the definitions of Monte Carlo monitors, then you can get idea what kind of quality metrics exist on the market and how to use them. For the Spark, for example, yeah, the PyTest and assertions the simple way, but in this case, it means you need to actually come up with your own ideas, what you're going to test, and just code this. Another popular library is DQ. So DQ, I think something similar to Great Expectations. Maybe Great Expectations will work with Spark. But again, my tip is here just to understanding common sense use case, why we need this, what options we have to validate. And the best thing to use a cheat sheet here is actually going to the vendor and check what they offer in terms of monitoring. And then see, do you understand this? Can you implement this? Answering your questions about data quality. So you can outline something like this, those tests, then you can bring examples, actual problems you had in the past with the quality and how you enforce it. For example, myself, for every interview conducted in the past in Amazon, Microsoft, or other companies, I always ask about data quality topics, as well as I always ask about data modeling, dimensional modeling, and the performance questions. But this is very particular about the data quality and the data quality framework. I hope I answer your questions. I hope it is more clear for you. And if you never did anything about the testing, the next step, I suggest you actually run some kind of pet project where you will focus on the testings of your pipeline. And if we talk about BI tools, you actually inside BI tool, you can also create some kind of alerts and monitors. So you can implement the same rules in BI, for example, in Tableau, you can create alerts based if meet threshold or some kind of things. You can use another completely different approach for the data quality. For example, tools like Datadog, Grafana, they build specifically for those kinds of alerting and monitoring. So, for example, Grafana is open source, and Grafana may connect to your database using JDBC driver or data warehouse. Then you can define the rules. You can define all those rules there and also alert. The benefit of those tools like Grafana and Datadog that they actually can go beyond just sending alerts. They can also leverage their on-call idea that, for example, if you update the team, then there is issue. The question, okay, there is the issue and pipeline the fail. Who's gonna fix it? You couldn't expect that every engineer in the team or every analyst in the team actually 24/7 monitoring that issue. That's why it's better to implement the monitoring framework on call engineers. And even if data warehouse usually is not that business critical, it's not 24/7, but during the business hours, it's really nice if one dedicated person can look to the issues. And usually what we do with the data teams, we can set up the Slack channel. In the Slack channels, we'll set up alerting. So where the issues will happening and coming to Slack, maybe using just the simple webhook and integrations with ETL tool or BI tool that can directly send alerts, or even Monte Carlo as a service can send alerts into Slack. And then you have on-call rotation that every week one person from data team can monitor and constantly. This is all really nice and valid use cases for your interview. Just think about your past experience and think that you can add those options into your own experience. Thank you.